So, what happens when you need to change a massive live software system? The kind a global company relies on for literally everything, from making sales to shipping goods. Well, it's kind of like performing surgery on an athlete while they're running a marathon. Today, we're going to pull back the curtain on the digital supply chain, that incredibly disciplined process that makes this whole high stakes operation even possible.
And this makes you wonder, right? Why can't a developer just go in and tweak the live software directly? I mean, it seems like it would be so much faster. But that simple question, well, that gets to the absolute heart of why this whole carefully structured process exists in the first place.
So, to answer that, here's what we're going to cover. First, we'll look at the potential chaos versus the control that's needed. Then, we'll walk through the three systems safety path, our digital supply chain. We'll break down what a single change actually looks like, follow its journey from start to finish, and yep, we'll even talk about what to do when things go horribly wrong. Finally, we'll open up the playbook the real experts use to get it right, every single time. Let's get into it.
All right, first up, chaos versus control. And let me tell you, the danger of making direct changes is very, very real.
I mean, really think about the scale of the risk here. We're not talking about a website going down for a few minutes. An unmanaged change to a company's core system could literally stop them from taking sales orders. It could stop them from creating invoices, from shipping products. It's a direct threat to the business's ability to function and, make money. So, how in the world do you prevent that kind of chaos? Well, the answer lies in something called the three-system safety path. This is the bedrock of our entire digital supply chain. The solution is this really elegant three-step pathway. It all starts in DEV, the development system. Think of this as the design lab, a safe, isolated sandbox where new ideas get built and tested all by themselves. Once a change looks good, it moves to QAS, which stands for quality assurance. This is a full-scale test facility, basically a recent copy of the live system. Here, the change gets tested to see how it plays with everything else. And then, only if it passes all those tests, it finally moves to prod, the live factory. This is the system the business uses every single day. And this system is strictly locked down. Remember our first question? Why not change it directly? This is why. No direct changes are ever made here, period.
Okay, so we have a safe path, but how do we actually move a change along that path? Well, that's where the transport request comes into play. Let's break down its anatomy.
This little thing is a transport request, or just a TR for short. Honestly, the best way to think of it is as a digital shipping container. It's like a secure box that neatly packages up all the technical details of one single software change. This lets it move from one system to the next without anything getting lost or messed up along the way. Now, this is absolutely crucial. Not all changes are created equal. You've got your customizing request, which is the most common type. It's like redecorating a single office in a giant building. It only affects a specific part of the business. But then you have the workbench request. This one is far more serious. This is like redesigning the entire building's plumbing. It can affect the whole system, which is why you have to be so incredibly careful with these. So let's follow one of these digital boxes on its journey, all the way from the lab to the live system. So it all kicks off in the dev system, in the lab. A consultant makes a change and hits save. Right away, the system says, whoa, hold on, and prompts them to create a new transport request to put that change in. And here's a really cool safety feature. The system then locks that specific thing that was changed, so nobody else can accidentally mess with it at the same time. The developer marks their small part done, and then a lead consultant releases the main request. That's the moment it all gets bundled up and shipped out, ready for the next stop on the journey. When that package arrives in the quality or production system, the system gives you a kind of delivery report. These are the import return codes. A code of 0? That's perfect, a total success. A 4 is just a minor warning, something to check out, but it's usually harmless. But an 8? Oh, an 8 is a hard stop. It means the import failed, usually because another change that it depends on is missing from the system. And a 12? Well, a 12 is a critical error. That means it's time to call in the technical cavalry, the basis team. But what if a mistake gets through all those checks? What if a bad change makes it into the live system? That brings us to a really important topic: handling in-flight errors, or how to reverse a bad shipment. And this is the part of the process that is truly unforgiving. Let me be crystal clear. There is no undo button. Once a transport is imported into the live system, that change is baked in.
It's permanent. You can't just delete it or hit Control Z because the core database of the company has already been changed.
So how on earth do you fix it? You have to fight fire with fire. You do it by creating what's called a countertransport. You have to go all the way back to the beginning, back to the dev system, and manually change the setting back to what it was before. Then you save this reversal into a brand new transport request. And that new request has to travel the exact same path, DEV to QAS to prod, to overwrite the mistake. You're not undoing the error, you're creating a new correct change that replaces it.
Look, understanding this whole process is one thing, but actually mastering it, well, that's what separates a junior consultant from a true expert. So let's wrap this up with the expert's playbook, the real rules of the road. This is what separates the pros from the rookies. First, sequence is king, always. You move these things in the exact order they were created, or you'll get those nasty errors. Second, don't piggyback. Never mix unrelated changes in one transport. It's a classic mistake. If one tiny part fails testing, the whole thing gets held up. Third, document everything. Linking your transport number to the business ticket might seem boring, but trust me, it saves you hours of detective work down the line. And finally, a real pro tip, on big projects, you can merge a bunch of related transports into one big, golden transport to make sure the whole project moves as a single, error-free package. It's all about discipline. And you know, this whole thing brings us to this central tension in all of enterprise software. This rigid, disciplined process, it provides incredible stability. But does that control come at a price? Does it slow things down too much? So the question I want to leave you with is this. Is this digital supply chain the ultimate key to stability, or is it an unavoidable barrier to the speed and agility that modern business demands?